Good morning or good afternoon, depending on where you're at. My name is Atarut Azizi Namini, Director of the IBT/ABC UTC. Very warm welcome to more than 950 sites, that is correct, 950 sites that have registered to listen to our July 2025 monthly webinar. We are delighted to bring to you this month a very interesting topics on use of the drone technology for in bridge application. We are delighted to have with us Jesse Escamilla with the Alaska DOT and Ryan Marlowe, UAS Program Coordinator. During the registration process, we have received a number of questions and we are going to try to answer them as time permitted. We are expecting lots of questions for this webinar, and this webinar will go, it might go up to 20 minutes after the hour. So we usually finish 15 minutes after the hour, this webinar, because of number of attendees, number of the questions that we are anticipating. We could go 20 minutes after the hour. So if you have additional question, please by all means post it on the dashboard and we'll try to get to them as time permitted. Couple of news, again, our 2026 World Bridge Engineering Conference, which previously used to be International Accelerated Bridge Construction. The name has changed because we are covering many different topics related to the bridge engineering. It is going to take place during the December 1st and 2nd at Hyatt Regency Hotel downtown in Miami, Florida. The conference is sponsored by U.S. Department of Transportation through our IBT ABC UTC. We like to say thank you to 33 state DOT who are co-sponsoring the conference. The platform to submit your one-page abstract online is open. The deadline to submit your abstract is February 20 of 26. Please, by all means, this is a great opportunity to share your knowledge with the bridge community. Each of our last conferences have attracted more than 700. We are expecting even more attendees for 2026 World Bridge Engineering Conferences. There will be travel scholarship available for state DOT employees. We have reserved a block of rooms at the special conference rate. December is a very busy time in Miami, so stay tuned for that. There's also opportunity to exhibit at the conference. So if you go to our website, you can get more information and reserve your exhibit booth and so on. So again, the deadline for submitting your abstract is February 20, 2026. At this point, I'm going to turn the screen to Kathy Kroll, who is going to share with us some additional news related to bridge engineering. Kathy?
Thank you, Torad. My name is Kathy Kroll. I'm the co-director of technology transfer for the IBT ABC UTC. I want to thank you all for joining us today for what is our 172nd monthly webinar in our monthly webinar series. Before we get started with the presentation, I'd like to share some announcements with you. I'll start with some announcements from our partner industry organizations. First, the 2025 Western Bridge Engineers Seminar will be held in Tacoma, Washington on September 2nd through the 5th. This event is presented by FHWA and the Western States DOTs. I've not had the privilege to attend this event myself, but I've heard that this has some of the best content and it's very valuable to all attendees, not just Western States engineers. Attend if you can. Registration is open. Next, the Precast Prestressed Concrete Institute will be hosting the 2025 PCI Committee Days conference from September 16th through the 20th in Chicago, Illinois. Registration is open. Next, the AISC NSBA will be sponsoring Steel Days 2025. This is a nationwide event to be held October 20th through the 24th that offers steel enthusiasts, both young and not so young, opportunities to learn about careers in the steel industry. Next, ASB, the American Segmental Bridge Institute will be holding their 37th annual convention in Bellevue, Washington, October 27th through the 29th. For all of these events, follow the links for additional information. The next slide is a different kind of announcement. We'll be sharing one interesting piece of information from the AASHTO Committee on Bridges and Structures each month. This is actually the same topic that we talked about last month because we want to make sure that we get the word out about it. Please check out the Bridge Deck Preservation Tool. This valuable resource is the result of a pooled fund led by Iowa DOT with participation from FHWA, Indiana, Iowa, Minnesota, Missouri, New Mexico, and Texas. This is a project-level tool for comparing options for bridge deck preservation for a specific bridge that's a candidate for preservation. The tool can optimize for life cycle cost or for service life extension. The tool is hosted by FHWA's InfoBridge website, which allows it to harness the data collected by bridge owners in accordance with FHWA's National Bridge Inspection Standards. From there, you provide some parameters, and the tool will provide suggested actions. The tool gives suggestions with cost comparisons. The cost in the system can be modified to align with your state, or you can use the costs in the system to get an idea of the relative cost of various actions. This really is a valuable tool. Kudos to Iowa and the pooled fund members for making this happen. Please make use of this tool and share the link with interested colleagues. Now for a few of our own IBT, ABC, UTC events. Our next event is a quarterly research seminar to be held on July 25th, which is next Friday from 1 to 2:15 Eastern. It will be on the development of low-carbon concrete materials infused with biochar for bridge applications. This seminar will be presented by our partners at Texas A&M. The next monthly webinar will be held on Thursday, August 22nd from 1 to 2:15 Eastern. Note that this is later in the month than our typical schedule. The featured presentation will be on smarter steel bridge design to accelerate project delivery. We'll be joined by industry expert Frank Russo of Russo Structural Services and Vin Bartuka representing NSBA AISC. Please mark your calendars and join us for this interesting presentation that will provide information and resources to promote efficient steel bridge design and constructability through standardization and innovation. Last announcement in regard to our annual in-depth web training. As many of you may know, each year our advisory committee selects a topic to provide more detailed coverage. Our topic for 2025 is Simple for Dead Load, Continuous for Live Load Steel Bridge System. We'll be learning about the history of the topic and how to design the system. We'll be presented with case studies by both Missouri and Nebraska, and we'll hear from the construction industry about fabrication and constructability. Registration is open. This is all for our announcements, but before we dive into our feature presentation, I'd like to go through a few housekeeping items. Most notably, the IBT ABC UTC will be updating the GoToWebinar platform. There have been some recent issues with delays between audio and video. We expect this update to significantly improve your experience. This update will take effect prior to our July 25th research seminar and will be in effect for the next monthly webinar on August 28th. The screen looks quite a lot different, sort of like dark mode, but it has all of the same functionality. And as a bonus, attendees will also have the ability to log in using mobile phones. If you have any difficulties with the update, see the support link on the screen, or you can contact Frey Pozo-Laura or me at the email addresses on the screen. And for our standard housekeeping items, as many of you know, these webinars are recorded and posted on the IBT ABC UTC website in the section titled Monthly Webinar Archives. So you can access this and all previous webinars for future learning and to share with interested colleagues. I'd also like to point out that a PDF version of today's presentation is provided in the GoTo dashboard on the right side of your screen. You can download these PDFs during the training session. They will also be posted to the archives. Lastly, this presentation will be followed by approximately 15 minutes of question and answer. Please post any questions that you have to the question box in the GoTo dashboard. With that, we'll begin our feature presentation. I invite the presenters to turn their webcams on for introductions. We're very happy to welcome Jesse Escamilla and Ryan Marlowe from the Alaska Department of Transportation and Public Facilities. They will be sharing the innovative ways that Alaska is making use of unmanned aircraft systems, or drones. We welcome both of you and will now turn the screen controls over to Jesse.
Good morning, everyone, West Coast time, and good afternoon, East Coast time, people. My name is Jesse Escamilla, and I am a bridge engineer with the Alaska Department of Transportation and Public Facilities, where I work in the bridge section based in Juneau, Alaska. I manage one of our 2 design squads, and obviously my primary focus of work is bridge design, helping to funnel nearly half of all bridge projects in the state. However, I also serve as a bridge inspection team lead for both routine and NSTM inspections, and I hold a Part 107 drones pilot's license. Unofficially, I am the drone program manager for our bridge section. I have over 20 years of bridge design experience, starting in the private sector, with the last 12 years here at this department. I've had the opportunity to be involved in everything bridge, from design to inspection to emergency response, and more recently, the integration of drones into our workflow. Before we dive into the main presentation, I'd like to take a few minutes to introduce you all to the state of Alaska, the Department of Transportation, or as you often see it, aka DOT&PF, and share a bit about who we are and what makes our bridge program unique. Alaska DOT is a department of doers. We're often forced to think outside the box, and more often than not, we're planning and implementing at a moment's notice. That's because we work in one of the most rugged, expansive, and dynamic environments in the country, and our infrastructure reflects that. To give you a better understanding, Alaska experiences more seismic activity than the rest of the US combined, as shown in this 2024 seismicity year in review map by the Alaska Earthquake Center. We have more coastline than all the other US states combined. Our rivers are fed by glacial melt, producing highly liquefiable, silty soils that our roads and bridges must cross. And in the interior, we experience seasonal extremes with temperatures ranging from near 100 degrees in the summer to -60 in the winter. We're a team that bands together in times of crisis, and one of the best examples of this is our department's response to the 2018 Anchorage earthquake, a magnitude 7.1 event. Crews from across the state mobilized immediately and converged into Anchorage. Bridge inspection teams were on the ground within hours, and critical routes were reopened in record time. 374 bridges, or nearly 1/4 of our state's inventory, were inspected and assessed by our staff within just 4 days. Here in the bridge section, we handle much of our work in-house, including new designs, retrofits, rehabilitations, inspections, research, and emergency response. In fact, some of our most recognized structures were designed by Alaska DOT engineers, and we're proud to continue that legacy today. This list includes the Sitka Harbor Bridge, built in 1971, and one of the first cable stay bridges in the US. The Gastineau Channel Bridge, a post-tension segmental balanced cantilever bridge built in 1981 and located just down the road from our bridge office here in Juneau. More recently, the Seward Highway 75 to 90 Road and Rehabilitation Project. It's a corridor project that replaced 8 aging bridges that were seismically vulnerable along Turnagain Arm, all designed in-house by our bridge section. That project has been recognized nationally, winning the ACEC's Engineering Excellence Grand Award. And I'll close this intro with one last project on the horizon, the Juneau Creek Bridge. This bridge, designed in-house and is part of the Cooper Landing Bypass project on the Kenai Peninsula. All girders are now erected, and this bridge will be staged for a full launch next summer. When complete, we believe it'll be the longest completely launched bridge in North America, spanning the 250-foot deep Juneau Creek Canyon near the Kenai River. This gives you a quick snapshot of what the work we do and the environment we do it in. We'll now shift into the main presentation, where Ryan and I will walk through how drones have become a practical application and powerful tool in our bridge inspection program, not only for routine inspections, but also for emergency responses, monitoring, and project support. So to kick things off, I'll hand it over to Ryan Marlowe, who leads our UAS program here at DOT&PF, to introduce himself before we dive in together.
Thanks, Jesse. As Jesse alluded to, I'm Ryan Marlowe, the UAS program coordinator, and I've had the honor of breaking a lot of technology with Jesse over the years as we trial it and integrate it into Alaska. You know, we definitely have a saying, if it works in Alaska, it'll work anywhere else. And that is very true. And we're very excited to highlight some of the items that we're working on today and with the rest of our partners across the nation. So a little bit about myself. I'm a certified mapping scientist with UAS. Technology as far as LiDAR, GIS, survey, integration, all of these different fields that combine together and act as the spokesperson for the department to try to get folks like Jesse and the rest of our team underway with these technologies. So a little bit about our drone program. I always like to talk about how our drone program is funded first, because this always it starts to make a lot of sense. We work with federal highways, Everyday Counts, STIC. You'll see SMART grant. There's a lot of items when we're looking at this, how we tie all these together. But one of the main items that I really believe has made us so successful is our one-to-one growth ratio. When we're looking at technology, treating it like a laptop, you know. I, for one, am not Jesse. I can't go into the field and inspect a bridge like Jesse can. And so when we're looking at how we apply these technologies, we're really looking at drones as tools. But you can see here from our UAS program just the extent to which we cover, from avalanche, rock slide, airport, research and development, advanced air mobility, survey, construction, and bridge. So, and then down on the bottom right, avalanche programs, as well as some of our VTOL and fixed wing systems, all of those as we're looking at this growth chart, how these things apply to our drone program. Now, you'll see this video, it's probably going to be a little choppy for you, but basically what this is going to be looking at is all of the different technologies that we've done, our partners, how we're applying these technologies, LiDAR systems for runouts, robotics, and using robotics across the way for allowing for us to do wildlife mitigation at airports, flying in snow, asset management. We talked about avalanche dropping. All of these things, the basic primary technology is UAS. And then, of course, how we share that data as fast as possible, getting out of these data silos, allowing for us to do things safer and faster. And really the whole point of unmanned, which is to allow for us to have these technologies that remove us from those areas that are unsafe. So we're very excited to show a lot of these technologies, how we're applying it to digital construction workflows, how we're flying remotely, all of these partnerships we have with our stakeholders, how we're building, you know, assets and bridges and pulling all of these things together, all with remote data. And then many times having a single individual go out and collect this data. Those are some of the major, I don't want to say low-hanging fruit, but a major milestones that are allowing for us to do far more with less across the state of Alaska. I know every time we have these, people are always asking, hey, what systems are you using? And I saw in some of the questions that had been pushed out, how are you guys using DJI systems? We definitely use DJI systems. We're still integrating a lot of the American-made systems, but if somebody was like, hey, what are your top favorite systems within your department right now? These are the ones that we use. Now you'll notice they're all pretty comparable in specs, but the big item that we're starting to see, remote operations, we have weather minimums that we're starting. So we're able to fly these in icing conditions. We're able to fly these in places where we normally would have systems failing, underneath bridge decks. We have EO and IR cameras, flight times, but remote operations and live streaming is really where we're starting to see a big breakthrough. And a lot of these meet the minimum requirements for us to take them on board commercial air carriers or chartered flights as well. So with remote operations, you're starting to see kind of a repeating pattern. All right, now we can take off, we can fly, we can stream videos, we can share information, now we can add teams. So we have folks that are we're constantly evaluating all of the different technologies. Right now, we're testing the difference between, of course, DJI and Skydio. This is one of Skydio's Dock 1s, the X2 platform, and we're also testing it on the X10 platform with their Dock 2. But all of these items are allowing for us to fly beyond visual line of sight. So the state of Alaska operates under public aircraft status, which is 40125, and this allows for us to operate these systems in pursuit of emergency response, critical infrastructure inspection, code enforcement, all allowing for us to allow these systems to be installed next to crucial infrastructure and deployed at a moment's notice. So when we're looking at kind of the future of, hey, how are these systems saving time and money? We can definitely see the future of every bridge might have 2 of these. I know in California, they're looking at installing these in different places on both sides or possibly on the bridge to be able to dispatch immediately to go look at stuff and saving hours and hours of time of just getting set up and getting things out of the way. But of course, our partners with Collin Aerospace and our ability to integrate these with mesh radar and test these with other partners, this is really where we're looking at the crucial investment in the future is how do we automate, but how do we allow us to go and look at things? We just had a big earthquake. You know, if we had these systems at all of our places that were within that 7.2 or 7.3 earthquake, we're able to start looking for critical failures immediately instead of waiting on reports to come in. So this is a key item as we're partnering with the test sites and allowing for us to get these systems in the air, tested and evaluated in these environments. And then, of course, the picture of the Skydio dock. So I know a lot of the questions that we saw came in was, you know, asking about brands and manufacturers. We're very excited. This is something that has been a long time coming. We've been working with California and Alaska DOT, but these are what we'll start to see on different projects, allowing for us, they do meet the NDAA compliance requirements and allow for us to fly as American made, but these docks, the automations, the workflows, you know, it does give you the allure of having weather and camera systems on sites, but then being able to take off and go and fly those missions either autonomously or whatever you need to go see in real time. Now, Jesse's going to show you a lot of stuff today, but I always like to show the back-end workflow. Great example here. So we deployed drone in a box up to a Sag River washout. This is up at the very top of Alaska. And normally getting imagery, satellite imagery, this would be a hard one, but we were not only able to get daily imagery, but we were able to get twice daily imagery. So we dropped a drone in a box out there. We had a Starlink connection, and you can see the workflow that we've designed here. We've been partnering with Esri to use their Esri site scan. But really what we have here is we have a tool that's deployed remotely. We can dispatch it. I always tell people, think of like an office printer. You can send a mission to it and just sit there and watch it fly. Of course, we're coordinating with airspace and all of our requirements with FAA. But as soon as that data uploads, we're getting imagery in about 30 minutes to an hour, which would take days previously where we'd have to send hard drives back. So right now we're seeing about 15 to 20 terabytes of data collection a year using docks, but we have far more docks on the way and we're starting to watch this number skyrocket. But from there, we can drop it down into imagery and we get at these out of these silos. So the imagery is created once, it's available to all of our internal and external environments. And you can see LiDAR, GIS, vector data. What you don't see connected on this now is video server and Excalibur, things like that. So all of these technologies are finally streamlining on the back end so they can plug and play with all of the tools and we have a reference and authoritative data set. And then, of course, with that reference and authoritative data set, the ability to now tie these into dashboards. So down in Juneau, we had our flooding where we had a glacier outburst that came through town, pretty high speed erosion, but using GIS associated with imagery, associated with window surveys, we're now looking at the ability, we can do full incident command, we can collect everything correctly the way that FEMA needs to see it. And in many instances, we're doing this with limited crews. This is one thing that Alaska is getting better and better at is how to do all of these items with the support of an entire team remote, where we have teams that are building dashboards, we have teams that are building apps in real time, but our crews on the ground are able to build these and have these inspections in real time and create that data so that we can apply and get refunded for these emergency responses. So.
And I will go ahead and take back over for a little bit. Thanks, Ryan. And talk about how we in Bridge Section use what Ryan has done for us and built drones, our program, and implemented drones into our section. I like to think we have a practical approach to this. And so part of that practical approach, I mean, first step, I don't have bulleted here, but it's really to have a Ryan. I think every Bridge Section who's going to utilize drones needs a Ryan on the back end to do what he just showed and what he does so that we can work seamlessly and sort of try and push and break what Ryan's rules are built so that we can implement. And I'll show you how we do that here. And the first step for our practical approach is that we encourage all of our bridge section employees to get drone licenses. So looking at our staff chart, we're a small DOT. 24 employees, I think, is what we have when you include our sections here. We also have a foundation section, as well as a single person who's in there. But we're a small bridge DOT. I think 24 positions in total. But we encourage drone pilot's license. I think there is 7 of us right now. There's 2 more of us that are also going to be getting a pilot's license, up to our chief bridge engineer, who she's on this presentation right now. So now that I say that, she's forced to get it this year so that I can add her to the box for my next presentation. And I'm going to show a couple other slides that show that we wear lots of hats. So even though I lead a design squad, you can see that most of us also put on our inspection hats in the summer because we're smart Alaskans and we don't inspect in the winter when we can. And so we are all also inspection team leaders, up to, again, our chief bridge engineer, Leslie, who also goes out typically 1 trip a year to go get hands-on and touch bridges. Same thing with NSTMs. Those are also spread amongst our department. We're sort of jack of all trades, masters of none, maybe, so we're a little bit in everything. And that's one of the approaches. And as I talk with Ryan and how we sort of figure out how to use these things, it's because we wear so many hats within our department. So the program that we built here, Bridge Section, is sort of built out of need, not for the sake of technology. And what I mean by that is we're not just inventing things and doing things to push boundaries. It's really out of the need that we have. So if you look at our state and our inventory of bridges, we don't have very many comparatively to a lot of other states. We have 1,100. So from the last time I pulled this pin set, 270 minor structures or so. I'm pretty sure this has grown slightly since then. You can see it's spread amongst our highways, our major corridors, but we're definitely dotted through a lot of Western Alaska, the Aleutian Islands. And for those of you taking the cruise through Southeast Alaska, there's lots of communities through here that are roadless, that you can't jump from one place to the other. I talked about our staff. Again, 2 design squads, 1 bridge management squad, a hydraulic squad, and a foundation engineer. So we designed 95% of our bridges in-house. Those are, like I mentioned in the introduction, those are new bridges, replacements, retrofits, rehabilitation. Bridge inspections, we do 100% of all routines in-house. We do 90% of now NSTMs in-house as well. The only ones we sub out are anything that requires rope access. So the point I'm getting with this is how many hats we wear, right? And our drone pilots right now are 7. So we're sort of, we have our hands in everything. We're designing them, we're inspecting our bridges, we're maintaining them. It's a really unique position, I think, to get so hands-on and to be able to sort of be in every aspect that is bridge design. The other needs that we have, well, so this is your cell phone data. Last time I pulled this is your 5 and 4G maps for where most of you are looking at if you're down south, or, well, okay. So let me clarify that. When I say down south, that's pretty much everywhere that's not Alaska. So even you in Washington, Minnesota, and North Dakota, you're considered down south from us. So for point of reference. But if you look at my Alaska map for my 5G cell phone data coverage, you can see that we are very sparse, right? So we have lots of communities, we have lots of bridges and highways that are not connected by cell phone data. So our everyday use, we have to be inventive and find ways to communicate with each other. And then let's talk about the scale. Our bridge office is here in Juneau, but if I overlay this actual state map onto the US, you'll see that we stretch from Georgia, Florida to California, from east to west, and then again from north to south. We're all the way north of Minnesota and down to Texas and Florida. So our scalable, think of the logistics of having to coordinate and respond to not only your routine trips, but obviously, as Ryan and we're going to talk about later on, unplanned emergency events. So now let's get to the drones that we worked with Ryan. So we sort of have a rule. We have a locker with our drones, and because our inspectors have their licenses, they basically check them out as they would a ruler or a measuring tape. It is just a tool and toolbox, and the inspector can use the drone as they see fit. In its basic sense, it's a camera with wings. This is a video that hopefully this plays for you all. actually, it's not playing for me right now. Oh, there it is. So this is we've had bridge strikes at some point, right? This is Gastineau Bridge, a barge traveling underneath with a crane, with the crane up, struck the underside of this bridge. This was 2020, just as we were implementing our drone program. I don't think we actually had it on the ground yet. We had drones ordered, but they were not quite here yet. But this shows you the before application of technology at that time. It was GoPro on a stick or camera on a stick to be able to access this tall bridge of where it struck. It was either that or the tried and true method of spotting scopes from the ground. And yes, we were able to actually assess and see the imagery that we needed to basically say that there's some cover concrete that was spalled off, but we don't see any exposed strands. However, the response time it took to get this imagery to go to a store to buy a piece of conduit so that we could attach a GoPro to go down was hours, maybe half a day to actually figure out the logistics of actually going and then finding this location. And nowadays on our routine trips, we have bridges that cross raging rivers in steep canyons, dangerous locations. We're not a state that puts under bridge inspection trucks for all of our routine trips. Instead, we use discretion, and we'll plan those trips accordingly if need be, or if flagged from a previous inspection, or if we know that we need to look at something. But otherwise, we're on the ground. And so now having a drone be able to get underneath these rivers and get the imagery we need from around pier caps that we wouldn't be able to access before. Our first set of eyes to see if we then need to schedule to have an underbridge inspection truck come. That's where this real tool comes in. Our tall rivers, we're littered with these in Alaska, this terrain that has tall bridges over braided rivers, and you can't access piers in the middle. I mean, this bridge is already 80 feet up in the air to begin with, so accessibility is already difficult. But being able to fly a drone real quickly from the shore and get photos of all the bearings, the pier cap, the foundations, take a look down and scan this over, it's just data and information we were not able to collect. So this is the basic sense of a drone, is just it's a camera with wings, and get it out there and get photos that you couldn't get otherwise. It's supplementing our inspection. We're not replacing inspections. It's a supplement, and we do take them on NSTMs as well. They will never replace hands-on. I'll clarify that, but they can be used supplementally. Now we're gonna sit on this a lot because we're gonna talk about how we're pushing technology to get drones and push this as far as possible to get data. This was a lot of experimentation early on, and it was through that experimentation that we sort of figured out a good system. So this is O'Brien Creek, and I was on a routine trip. I saw a little bit of erosion that was happening on one of the corners. This is satellite imagery, so that's why the quality image is not well. I thought, well, we have some software built in that can use pictures to make a top-down view or orthomosaic. And so I hand flew. So I think part of the struggles of drone implementation is the need to learn new software. And I think I told Ryan early on that I do not want to have to learn another piece of software to map a mission out that's going to go and pragmatically fly this drone around in a grid pattern and then post-process that. I want to be able to, in the field, make a decision, fly a drone, and you can see how sloppy my lines that I flew was. But I took overlapping photos from varying heights, and from that, I'm able to capture a real-time live orthomosaic. So I stitched those photos together, and it's now able to capture. And if you look on the bottom left bank, you can probably see, let's see if I can get the highlight spotlight. You can probably see the erosion that I was trying to capture that's on this shore right here over the riprap. You can see that cut. And so I took this photo, and that's kind of all I thought of it. Like, this is cool. But then so that doesn't let me advance. Okay, and so the next time I was there, I happened to be there at a high flow event. I was able to do the same thing, repeat, and take another photo, those overlapping photos, and now you can see the erosion. I just happened to be there at that time. As this bank was eroded away, trees were falling in, and this river was cutting, trying to take over the approach on the far end, getting around the riprap. So, I mean, that was great to have that information, and then being able to compare it. So we use software that Ryan got for the state, and this is called SiteScan, that we keep this data. And so I'm not doing anything but uploading photos at the end of the day, and I have this product that's available, and built into that is sort of a history. I can pull all these data points from when I've collected this data and do comparisons and sliders. This is nothing that I had to learn other than dragging and dropping a bunch of photos into the software and letting it figure it out and tell me that it's processed and I can compare. So this is Ptarmigan Creek, or Ptarmigan Drop. It's a large culvert that I had to do an initial inspection for. So that means collecting all the data, culvert length, how long it is along the length, along the skew, fill height, culvert size, and whatnot. So I flew this drone out for 2.5 minutes. I launched it, I did an orbit, 2.5 minutes, 4 lines up and down. And this will play showing you the results of that. Again, I'm able to capture this in real space. I can take this orthomosaic and bring it into CAD and measure skew angle to verify that it's either 90 degrees, 10 degrees, or was built to plan. But the cool part of this is that now I have a cloud in space. I have this 3D point cloud that represents the culvert. And I can do so much with this now. Well, for one, this survey, if you will, not really a survey, but I have this. So any changes that happen from this, I can always do this again and compare it to. But all this geometric data is there as well. I can pull lines from the top of one end of the culvert to the other end of the culvert, and I can see the cross slope of the cut of those tie points that are through there. So that means I know a culvert inlet, I know a culvert outlet elevation. I can snap a theoretical straight line from it and measure the fill height of the roadway at that theoretical straight line versus guesstimating from the inlet or the outlet. I'm sure we've all seen those culverts that rise and drop very, very steeply, so it's kind of hard to estimate what your fill height is. Now, for a culvert that has 30 feet of fill, this really isn't important, but it shows you the geometry of and what we're able to do. So let's look at one of our first emergency responses that we've done. And this is the Koyukuk River Bridge. We had an email come in 8 a.m. And typically, I find that the emails that are 1 and 2 sentences long usually are the ones that encompass more of your time than it should. And so we talked about Koyukuk River and our logistics, right? We looked at our map earlier. So the Juneau office, where our bridge office is located, is here. Call it in Tennessee. And the Koyukuk River Bridge is on the Dalton Highway in maybe South Dakota, right? So for you Alaska reality show fans, that's the ice road. So it connects Fairbanks to Prudhoe Bay. So a lot of commerce and oil field work they depend on this. This is a lifeline for our infrastructure. So this is the picture that came in the email showing the damage. It would have been nice if it was focused on, so I'll sort of point out where the damage is here. So the leading pile looks like it was pulled back, peeling apart the pier cap or the cap of sorts. You'll see, we'll look at some details in a little bit, and maybe pile 2 is also severely damaged. So what could have caused this? This is just a neat thing to kind of show you all since we're talking Alaska. So this was satellite imagery in early May showing the winter conditions. You can see the road that snakes across the river. And then in mid-May, the snow is gone. So in Alaska, we have what is known as spring breakup. So the winter rivers that are frozen will then, at some point, things warm up enough that they tend to release in a pretty violent manner. And what's known for our bridges, especially our older bridges of like the 70s vintage and earlier, is that they are our narrowest crossings. So these ice flows will jam up on the piers and at the bridge locations, grab onto the piers and yard on them, and the piers themselves will sustain damage. And in this case, this is most likely what caused it and ripped apart the pier. So this was a 7-span bridge, 2 small approach spans, 4 main spans, and then 1 more approach span. Deeper spans for the larger 60-foot spans and shallower one. You can see that the girders frame directly into the piles. This wasn't intended to act like a cap that transferred forces down to the piles. The shorter spans did have a W shape that served as the cap. And then at that location where it switched superstructure depths, there was this built-up section to make up that difference. So what's our challenge here, right? We're in a remote location. It takes a long time to travel and get from Juneau to up the Dalton Highway and into this location. It's 2 commercial flights plus at least a 4-hour drive. When you get there, what can you see? You have lack of cell phone data, no communications. Our under-bridge inspection trucks are based out of Anchorage. So what are we going to do? Are we going to wait for bridge inspectors and engineers to arrive? Is it worth deploying equipment and telling the U-bits start driving now? Can they even be used once they get there? Because all we have is one photo right now to go on. Are there alternatives? Well, I think you kind of know where we're going, since that's the moral of this presentation, right? So release the drones was kind of my moniker that I would use anytime a situation arose, and we've been doing this more and more now that it's just so casual. New to us at the time, this was 23, I believe. We had heard anecdotally about live streaming. I think Ryan kind of mentioned to us that live streaming is something that's coming. We didn't have unlocked yet, I don't believe. And I called Ryan and I told him of what happened. He happened to be in the area and he said, "Oh yeah, we can do this." So he called our industry reps with Skydio and with DJI, I believe, to unlock live streaming for us for free, basically, just because we're responding to an emergency response. In Fairbanks, we have one of our employees who just got his license, I believe, the week before. He had not yet flown one of these drones. He just got his license as 107, and he had yet to fly them, one of the new ones that were available in Fairbanks. Also very new to our inventory were mobile Starlink backpacks. So as we were looking for ways to do this, we said, well, let's set up a hotspot at the bridge, see if all these puzzle pieces that we've never used work together, and we can set up a live stream with the Juneau office. So since I have the back end of the Skydios and the DJIs, I can see when they go live, and I can, we'll just set up. We're going to plan a meeting there the next day at 12 p.m. So let's screen share. So why not have it host a Teams meeting? So if I'm having this screen on my end, then I can host an online meeting, share my stream. If we're doing that, then we can invite all bridge staff who need to be there, Northern Region Construction, design folks, as well as a contractor who happened to be in the area. They had a project going on 80 miles away, which for Alaska, that's nearby, right? That's Alaska close. And so odds are we can use this contractor for emergency repair. So he's located in Anchorage and Oregon. We're going to hope all these things sync up, and the next day I'm going to start the meeting at noon, and hopefully the staff that are traveling to the site can actually get there at noon and set up their hotspot to connect with us. Well, that is actually what happened. So you're looking at, this is the DJI platform. So this is the Teams meeting that you're seeing, and I hope this stream is coming in good. You can see on the left on the dashboard where the drone is in space. You can see by the little triangle which direction it's pointing. So I can sort of guesstimate. You can see he's looking at a pier. The pier is a little off in location in the satellite space, but close enough for us to figure out the location. The downside of the DJIs is they have trouble going under bridges, which is something I pushed Ryan early on, is that I don't need to look from the outside. I can do that myself. I want to be inside and underneath the bridges. So I will say, though, that the camera quality and the results that we get out of it is really good. This is the DJI M30. I believe this has 2 controllers, so there can be a pilot who's flying and a second person who's controlling the camera itself independently. And that's really useful so that you don't have to try focusing on 2 things at the same time. And because this is a Teams meeting, Ryan, while flying, also has an earpiece in on his phone so that I can tell them where to fly, what to go look at. There's no bridge engineer on site, but the bridge engineers are directing the cameras where to go. The other drone that we use quite often is the Skydio's S2 Pluses. These little blue guys have become our bread and butter. For one, they're small. They use an awareness. They have 3 cameras on top and 3 cameras on bottom that are not their primary cameras. They use those cameras to create point clouds and basically get into tight places. As we get new pilots on board with this, we basically let them fly and we tell them, try and crash this into a bridge and watch what it does. So you start to trust the bridge itself, or the drone itself, to actually not impact things, and then you can focus on your job, which is inspecting bridges. From the back end, this is what Skydio Cloud looks like. I can manage and I can see where all the drones are in, or at least when they're connected to the network, where they're at. You can see our fleet. And before I get a question and answer popped in, I will admit that I name all my drones after Keanu Reeves movie characters. So all of them get a moniker. So as opposed to just Bridge, Skydio, S2, this, I decided to name them, and this is how I keep track of them. So during the live stream assessment, this is what it looks like. I'll learn when it gets pre-flight, and then I can see when they live stream. So this was a breath of relief, right? Once I saw live stream, I know it's going live at that point, and then we can hit play. And now you see the real benefit of the Skydio S2 Plus. It is underneath the bridge, right? So you can look at that mangled piece of pier cap that is pulled around. I am flying. If you hold your hands out 4 feet wide, this little drone is inside of a girder. Inside girders, 4 feet. It's on top of that mangled piece of pier cap. And these Skydio S2s, the beauty of them is that they can look up 90 degrees and look down 90 degrees. So you'll see this camera tilt up eventually, and we can capture every piece of bridge that we need to go look at. And again, we have a hydraulic engineer who has not flown this before, who is on site because he has the drone capability, the Starlink capability. The bridge office can guide him, and we can get what we need to assess the damage. So I'm just going to show a couple more video clips of more of the assessment he's doing, and you can see the versatility and how smooth it is to get to. But you can totally see the applicability here of we don't have a bridge engineer in harm's way, right? This can be expanded. You can be responding to earthquakes. You can go to impacts of bridge strikes where there's precarious, you know, your sort of first eyes in the field to go and assess the damage and see, is it safe for the public? Is it safe for me as the inspector or the engineer to be in the field at this location? Do I need to make a call to shut the bridge down at this point? The technology is there. So having the contractor on site was kind of neat because when we were done doing our bridge assessment, they had some questions about things I wouldn't have thought about, I will say, you know, a laydown yard, where are we going to stage, you know, where's our equipment going to go? They were asking areas of, you know, what looked flat. I believe Ryan said, well, if you want to, we can fly a quick mission and do an orthomosaic. So take those pictures, make that top-down view, even give you contours, and then you can have that in your hip pocket so you can plan. So that was something we did on the fly because we were able to, and having the contractor on board with us. So post-processing wise, once we got the data, this is a video clip that I hope is playing well, but it's showing all the images that Luke, our hydraulic engineer, took. And again, using site scan to capture this. You just dump these photos in, literally click and drag, wait a few hours, and you have a point cloud now showing the damage. I can take this into Civil 3D. I can go into Bentley or MicroStation. I have this to be able to measure, to look at deflections, to see, obviously the first pile is gnarled up and gone, but is the second also? You know, can that be assumed to have some loading still? Is the third pile the third pile damaged? And I didn't realize it because, you know, I didn't have measurements, but now I do. One of the other advantages of this, as opposed to just a point cloud, is that those images that created the point cloud are also stored. So I can inspect the point that was created, and I can see what photos created that point. I can go through, and so these are the photos that you see on the right being shuffled through, select one of them, and I have that high resolution photo. That was one of the ones that made that tie point. I can scan in, zoom into that photo. There's no need for me to photo document 800 photos. It's built into the system, and I have the high resolution image I need to, should I need to inspect something further and get more detail. I'll quickly talk about this. This is just the repair project that we did. Basically,
Jesse, this is Kathy. Sorry, can I suggest that maybe we just fly through the repair and just get back to some of the dashboard things. We're getting pretty low on time, so, and I know you've got some really great conclusions.
Yeah, perfect. All right, so the repair happened. Good news is the contractor was not surprised by any of it, and that it came out excellent. And within a couple of weeks, the repair was done and completed, and complete success project. No change orders, no questions. So emergency response. This is Suicide Basin in Juneau. We have what's known as a yokel up. This is an Icelandic term where the Suicide Glacier is retreating. We have a bathtub that fills up here every summer as snow and rain melts, and it empties in a big 6-hour period, 6 to 12-hour period into the Mendenhall River, Mendenhall Lake, and then floods. It exceeds any sort of predictable rain event that is like a 500-year flood. You'll see this basin rise up 80 meters or 250 feet over the course of the summer and then release out. And this was made popular, not popular, sort of famous a year or two ago when a house on. And you probably think to yourself, well, that guy built his house so close to the river, he sort of had that coming. Well, that's not really the case. He actually lost about 80 feet of bank over the course of 6 hours as that eroded away and took out houses and almost the condos to the right, as you see cantilevered out. So these are the nature events. And unfortunately, this is something that now happens yearly. We have 2 bridges that are along that path that we now monitor. And we're in ICS right now. We're meeting weekly because this is a coming up event that we know is going to come in August. And so that's, when I say ICS, I mean Incident Command. We have meetings weekly planning for this next stage. Last year it happened at night. We have a Skydio X10 that has lights. We can fly at night. It has thermal. So for this emergency response, you can see people on the bridge and the rage that this river happens or experiences. We end up deploying two staff, 1 pilot, 1 assistant. And the workflow we've seen really work is that we have someone, this is me, who is in the office, or in this case, I was in Washington State at my son's basketball camp when this event happened. I was the office person who set up the Teams meeting. I'm able to run the Teams meeting, talk to the assistant while the pilot is flying. This is the back end. I'm able to switch back and forth between thermal and RGB standard camera myself and not interfere with the pilot. So I have this capability from the back end, which means I can do screen grabs. I can go through and check river status concurrently while this is going on. I can have maps open and compare and see if it's jumping its banks, if we've had erosion. If we flew a mission the week before or something like that in preparation for this, I know where the bank edges were, right? My eyes on a screen are much better than a pilot screen that's looking down. So yeah, just sort of showing you the capabilities that we're able to do here. One of the other benefits that we have of this is because I have these eyes that the pilot doesn't. As he's pushed out in the night, I can also see where he is. I'm in communication with him. I can help assist him to sort of get back, go strafe to the east to get yourself in the center of the river, and then you can work your way back to where you are to land. And I'll let Ryan now talk about some of the other emergency responses that we've done.
All right, I know we're slammed on time, so I'll make this quick, Jesse, and go through here and kind of just talk about, we have the landslide in Ketchikan. You can see the same thing. Now we're tying GIS data in to look for, hey, there's buildings that are missing. So now that team item, we're pushing data to the field and we're able to see all that information in real time. We show up on site. This image is just stitched together in real time. So this is after the first 10 minutes of flying. We now have a full ortho. We have a project, or we have a slide path extent. We already have building footprints. We have critical infrastructure. This information is being shared with everybody immediately. Next slide. We'll probably jump through this one pretty fast, Jesse, on the next one, but just highlighting once again, landslide. We had over 150 remote scans of this, and you can see the detection change down below when we're looking for slope stability. All of this data is dumping into SiteScan. We then compress 150 scans together and say, hey, the slope's not moving. So pretty impressive when you see that same workflow that Jesse uses, we use for avalanche and landslide. And Kathy, we can switch after this one. The last item that I really want to focus on that ties all of these together, communications. Starlink, FirstNet, our ability to rebroadcast FirstNet. But you can see down here on the bottom, and Jesse, switch to the next screen real quick, our ability to track assets in real time and using their GPS location, that's really been one of the key factors. And Jesse's team has had, what we see here is we see all of our drones, we see all of our Starlink devices, we see all of our vessels, all of our connected vehicles. This has given us the ability to really see what we're using for Starlink, where our Skydio drones at, where our docks are at, and allowing for us to respond immediately by seeing, hey, what assets are in the area. So with that, Kathy, I will quit chatting and probably hand it back over to you.
All right. Thank you. Thank you for a great presentation. At this point, we're going to turn it to Paul Lives to moderate the question and answer. At the meantime, I'm going to give the screen to Ryan, I believe, who is going to be showing some, I guess, the flow. While the Paul is asking the question, I'm going to turn it to Ryan to show some footage of the drones. Am I correct?
That is correct.
Okay.
We had originally planned to show you one of the bridge projects, but the dock is unavailable at this time. So I'll show you guys the Skydio X10 dock that we have. So let me know when I can share that screen.
Yeah, we do have a number of questions. A bunch of them came in beforehand, and we have some that have come in during your presentation. But we'll go ahead and get underway. We have a few general questions here. The first one, what exactly is a drone? What would you use as a sentence or two to describe one? Tell us what one is.
Well, while I'm flying this drone, I'll explain what a drone is. A drone is a device that is unmanned in nature, sometimes autonomous. Thus the ability to have a flying platform with a camera or sensor on board that allows for us to remotely sense electro-optical, infrared, the ability to fly. You know, that's really what we're looking at, is tying all these items together is in a platform that is human removed.
Okay, another general question here. Are there any issues with the privacy of persons or vehicles recorded during drone surveys?
Absolutely. Fortunately for us, all of our critical infrastructure is located right next to where people live, daily business. So one of the big that we focus on is, you know, if we do have any sensitive areas, reaching out to those folks, reaching out to the communities that we'll be operating in. You know, we do a lot of pre-coordination to make sure that folks are aware that we're going to be there in the event that something is inadvertently captured. So we do have policies within the state of Alaska of what's considered loitering and what's considered public right-of-way. And we do our due diligence to make sure that those items are collected under the FAA rules and regulations, and any sensitive areas, like I said, pre-coordination and communication is key on operating these in those areas.
Okay, we had a question from someone that had a major bridge, and they said, what options are there to deal with unwanted drones around major infrastructure?
At the moment, counter UAS technologies are really one of the only options, and that's all passive. So documenting, myself with DOT, we don't do any enforcement on friendly or non-friendly, but we can only document, you know, what aircraft are allowed to be there, what are not. Counter UAS systems, we're seeing a lot of that start to take off, where we have airports, we have critical bridges where we're having nuisance problems. Documentation, so you can hand that information over. Think of it as like digital license plate readers or near RFIDs. It tracks them, it's able to see where they're taking off from, where they're operating from, and a majority of the time where they are, what their license plate and what their ID says. But those are some of the key items of counter UAS, is just how well you can document that information and give it back to FAA or their LEAP program for enforcement or follow-ups.
Okay. What is the potential for drone surveys replacing manual surveys in highway design projects? And how accurate are the drone surveys?
I'll be the first to tell you, drones are not replacing surveyors. Once again, they're a tool. Just like Jesse, I can fly a drone very well, but I have no idea how to inspect a bridge. I can remotely fly a drone with Jesse in my ear, but then again, that's kind of the beauty of this technology, is the ability for us to remotely view items to get the information we need. I think that's kind of where we're at right now, is we're figuring out where this tool resides. I always tell in survey, it's the same thing as when GPS came about. A lot of the old folks were not very excited because it was this fancy new technology. We weren't too sure. Now we're seeing a lot of the survey teams really implement and use these systems, LiDAR, building, topology, everything, streamlining their operations, and most importantly, keeping them out of traffic. You know, I think they're like, hey, we don't have to shoot centerline anymore. Yeah, please sign us up for these drones. So I think that's the key factor, safety, and adding that tool to their arsenal of assets to be able to collect data faster and more efficiently, and most importantly, repeatable.
Okay. This question is from an international attendee. We hope our translation is adequate. Can drones be used for applied geophysical tests for bridges?
Jesse, I'll give that one to you.
I don't know if I fully understand what he's implying to when he says geophysical tests.
Well, you mentioned certainly avalanches and landslides. You use them for mapping the extent of that, I guess.
I mean, I guess if you're looking for slope stability, yeah, Ryan's workflow and working with our avalanche and disaster response for landslides has proved that you can definitely detect change by comparing orthomosaics or top-down views from one to the next, and there's software that can detect those changes. So if that's what he's asking, then yeah, I would say yes.
Okay. We'll go to some inspection questions here. How often are bridge inspections performed in Alaska?
We follow federal guidelines. So routine inspections are every 2 years, and NSTM inspections are every 2 years. And within our state, we try to stagger those. So the NSTM bridges are getting looked at about every other year.
Okay.
So standard procedure.
All right. Do you intend to scan all your inventory as part of your inspection programs? Maybe to give yourselves a 3D model of what the bridges are to go with the inspection report?
That's one of the things that we found early on is believe it or not, there's such a thing as too much data. And it seems like no matter where you work, you're controlled by IT and admins, right? And so they yell at us with all the data storage that we hog up. And for bridges, I think we're unique in, we ask them they ask us how long do you need to store this data? And our answer is forever. We don't get rid of our bridge imagery. We don't get rid of photos. We don't. So we've learned that, for one, pictures are less space than videos. Videos are gigantic hogs. And so we've started, we collect imagery. And then how to be efficient with what you do. Like I said in my presentation, we don't have a rule to follow right now. It's up to the inspector to use the drone as they see fit. If they just want to use it for camera photos, fine. If they want to do an orthomosaic, okay. If they need to do a 3D scan for some reason, that's great too. We have toyed with the idea of making a 3D or digital twin when a bridge starts, so we have that base map in place. We have yet to implement that, but that's something that Leslie's on here. I haven't discussed that completely with her, but that was something in my head so that we had that data point there. And then, we can take it from later on, just like I did at O'Brien Creek. Once I had that data point, I can compare in the future any other time I want to.
Okay. Do drone inspections meet the requirements of the specifications for the National Bridge Inventory System?
No, they do not.
Okay. No. And do the drone inspections satisfy the biannual inspection requirements?
No, I do not interpret that to be something that can bypass any federal guidelines for inspections. Okay. It's a tool just like a camera and a ruler, so I can use it to supplement inspections when we go out. We don't intend on doing virtual inspections to replace us having to go in the field. We can use it to go and perform emergency inspections. If there's a reason, like Ryan is flying right now in Anchorage, he's flying virtually, I can direct him where I need him to go get what the information I need to make the call as the subject matter expert.
Okay. Can you use thermal cameras to inspect for delamination in concrete?
Yes, that is something that we're working on right now with University of Nevada, Reno as research. We're looking at using drones and thermal cameras to map out deck delaminations. There's been some mixed results. We've been experimenting with it this summer on inspections, and the results have been promising. We've been doing both chain drag and sort of spray painting rectangles and comparing that to what the thermal results show. The research with UNR is then going to go a step further and then take those images and then use AI to basically quantify those based on areas to help us spit out condition states based on square footages that I deem to be condition state 2, 3, or 4. And this would be great, similar to what Ryan's done before with landslides and comparing previous photos. I can see growth and change and delaminations. So I think we're close to getting there, and I think it is a practical application.
Okay. How do you determine it? How do you determine what level of detail is required or is necessary for your drone inspections?
Again, we have no hard rules, and I think that's what makes us in bridge inspection a little unique and maybe makes it more sustainable or an implementable product, right? I'm trying to break the rules and say, well, this is a camera. I don't tell you when you need to hammer when you're in the field, right? That's you as the engineer who's the bridge inspector. So if you need to hammer on something to see if it's loose, fine. If you need a drone to go out and take a photo, cool, you do that.
Okay, when do you fly, and do you have tips on how to get the best results?
So I think Ryan has told me try and break it, right? And I've crashed 3 of them, and I crashed less and less. I don't know if my skills gotten better. I think the technology's gotten better. Especially for us in Alaska, so we have to travel really far to get what we have to do, right? Like I have to go inspect a bridge. I have my inspection trip planned, and I'm on commercial flights and small flights, sometimes planes. When I am there, I will fly no matter what. If it's very, very bad weather, I can typically stay underneath the bridge and stay out of it, stay out of most of the weather, but I'm pushing the boundaries of what can be done. I'm in dark mode underneath bridges when it says the light level is too light, you know, and then I have to bypass it because I'm there to do a job, and that drone is my hammer. Well, it's a single-use hammer, but it's my hammer.
Can you fly them in the rain?
Yes, some of the drones that we showed you earlier, the X10 and the Skydio X10 is waterproof, and so there are pros and cons to some of the ones that are waterproof. The one that we showed you earlier, our bread and butter, the little blue Skydio S2 Plus, that one is not waterproof, but it is so convenient because of how small it is. It can get inside of girder bays. The X10's a little bigger, can't get quite as close in, but it is waterproof. So you have your tools when you need them. So you can get out there in cold. And Ryan, you've pushed it in freezing temperatures. And I know when the next earthquake's going to happen, it's going to be in the winter that we got to respond. That's just how it works.
Yeah, I mean, icing conditions, you know, we have type 4 glycol that will spray in some crops. There are some times where we have to fly. That data is more important. And that's the beautiful thing of the risk of, hey, we need to see, I know we had windstorms and I flew in 75-mile-an-hour winds, but Jesse needed to inspect that bridge and the bridge team. So it's like, that's kind of the cool thing is when we need to have that data in lieu of basically making sure the public is safe, we can push those risks appropriately as deemed allowed by FAA and still capture that data and share that live stream. So I think that's one of the cool things with this is we're not risking human life, and those are some of the metrics that we really start to use when we're out in these places to alleviate and get that data back as fast as possible.
Okay. Would this technology also be viable for tunnel inspections?
Yeah, I don't see why not. That X10 that we showed that was lit up at night, it has not only a spotlight attachment, it has a floodlight on top and bottom. And so I have used it in basically a tunnel. It's a viaduct that is walled off on 3 sides for multiple spans. And we've flown it inside in what is essentially a pitch black corridor to go and get us eyes closer to the underside of the bridge. So yes. Now,
okay.
Again, it's a supplement. It is not going to replace. So if you still need to get up there in person, you can. But if you need it for documentation, to take photos, to look where you need to go assess more, yeah, it can most definitely be used for tunnel inspection.
Okay, we had a bunch of questions about the equipment. You showed us a slide that where you showed some of them. There were some questions about the DJI drones as to maybe they'll be banned by the United States or anything like. Do you know anything about that?
We are hearing that, but I mean, until it happens, those are items that, you know, we definitely have to play by ear. We, of course, have diversified our fleet, and this year will be 50% DJI, 50% Skydio. And you even saw on a lot of our slide decks, you know, we're using both technologies, we're competing them, we're dual responding with them. Jesse's team, along with most of the teams, have both. And once again, we got two different hammers, so it's very important for us to know what works well, what we'd like, so that we can share those notes and build a better platform and product in long term. So yeah, definitely, you know, we're aware of it and just making sure that we're covered on both sides if or when that time does come.
Okay. I had some questions here about your brands and models, which you showed us, but also they said what processing software was being used, and also is AI being used to detect structural problems?
I'll talk on the software workflow, and then Jesse, I'll let you jump more into the AI. The software workflow, we're pretty agnostic to software platforms. When we're looking at our team, you know, we have 160 aircraft. We have a lot of folks doing different items. Some of our teams are looking for absolute accuracies, others are looking for relative. If I had to say, 95% of the department uses that model that you guys saw today with Esri, but we have a lot of folks that are still using Trimble, Business Center, and Metashape, and Pix4D, and I mean, it's really whatever helps you get that done, and you're comfortable with those workflows. You know, Jesse said it perfectly. A lot of folks don't have the time to learn brand new workflow. Building a lot of these technologies so that they can tie together. We have that authoritative data. And right now with Esri and Autodesk and Trimble, we have the ability to share geo information into those platforms without having to duplicate data, which of course is the other elephant in the room is, hey, we can't be duplicating this every step of the way. It needs to be from one definite source and go from there.
Okay, we're getting out of time. I'm going to ask Rick to come in, and there's still getting a lot more questions coming in. So Rick, do you want to come on?
Yep, sure. Thanks, Paul. Good stuff. Jesse and Ryan, got a couple things I'll hit on here there's a lot of questions, so we're not going to get through all of them. But one of the things, let's see, can the drones be programmed to identify fractures or spots that might need repair? You know, obviously you showed that one pier thing, but I was wondering, I guess there's a question whether you can program it to look at a specific area.
You know, as far as like mapping to look at the same exact area on a structure, if you're looking like at a very specific crack, maybe we don't do that in bridge section. Like, but I can real quickly from a bank, if I know where a crack is, and I've done this multiple times. Once you're really good at flying these things, and not even really good, if I know the location, I can go spot a crack from multiple spans down. If I know to get to Pier 3 and go over 2 floor beams and find it, like. So I have done that numerous times. If I know a target, and especially if an inspector's been there and put a crayon around it, it's super simple to see and document and see has it grown. I don't know if I would be doing repeated flights like how Ryan has talked about to get that level of detail, you know, to do repeated survey missions, if you will. But for structural assessment, it can definitely be done, but I would recommend hand flying.
So are you allowed to fly autonomously? And then are there risks associated with the RAS getting lost or crashing?
Yeah, autonomously is currently not authorized by FAA. Everything still requires a Part 107 pilot. Or if somebody has a waiver that allows for them, please let us know. You know, I think that's my favorite thing with all of this is we watch one person break it for the industry, and then the rest of us jump right behind them. So we're all pioneers. You know what we saw Texas doing, and California, and North Carolina, and Maine. We all watch those little wins that everybody makes, and we're progressing this together. So I think that's my favorite. We're in this together. Everybody's making these small incremental steps. The technology is getting more reliable. So yes, autonomy is not allowed I can't just schedule this flight to take off every 10 days. I still have to be the one launching it and moving that forward. But that's it. That is where this technology is going, is eventually, yes, the FAA will open up those pathways to allow routine and repeatable flights that have been proven safe to conduct automatically.
Was a question real quick about, you know, are the drones more than capable of working during the winter time? Obviously the cold affects the batteries and the different things. And I don't know, obviously a lot of the stuff you showed us was spring and summer, but. So.
Yeah. We've written a lot of our waivers so we can operate. I mean, it's mostly can your fingers work during the wintertime. So you'll see a lot of our waivers are designed that we can operate inside vehicles for exactly that reason. The last thing we want to do is have somebody sitting outside exposed. Batteries are dying. Yeah, we've had a lot of crashes because of cold weather, iPhone cables freezing. So yeah, we prefer the safety of the operator, and flying inside of a vehicle is pretty much what we do with a lot of these operations.
Okay. There's a question about what's the average cost, say, of a drone for kind of the level that you're using?
I mean, they range from the Skydio S2. I mean, it's probably the most affordable drone that we talked about here today. And the Mavic 3 Enterprises, Mavic 4 Enterprises, your starting range is $5,000 all the way up to, I think, 30,000 is what we showed today, between 5 and 30,000. Docks, of course, are still getting cheaper. So, but yeah, that's normally the range that you're looking for the enterprise functionality, and then of course the back end, the automated workflows into your enterprise environments that you already have set up.
Okay. Have you come across any situations where you haven't been able to use your drones?
Yeah, sometimes we get into airspace where it's too tight. Military airspace is a big one, especially with some of the DJI systems, which is really where we've been pushing. We, of course, are located right next to a lot of facilities and military airspace, so we've been switching over to Skydio for that. And then sometimes weather is just absolute miserable. We either have low-lying fog, high humidity, and especially for the onboard processing, it doesn't work in those conditions. So we still have to go back to the manual. And that's kind of the tool is like, hey, you have all these tools in your toolbox. Sometimes drones aren't the way to go, or get back in a helicopter and fly it manually. If we have landslides or we have bigger areas, I think that's where I say the low-hanging fruit. It's these small areas of interest, not entire bridges, not entire spans. The Bay Bridge, I know we've been looking at, it's going to take 3 drones to be able to map that. And take all day of pictures to be able to grab something. So I think those are big items. Is these drones can't just capture all these environments. You're stuck within a certain distance of safety and reliability with those systems.
Yep. And if I can add for bridge inspections specifically, we have the benefit of a lot of our bridges being either remote or over creeks and waterfalls, or so I can fly underneath bridges quite often. But if you're in a very urban interchange area, I'm not flying under a bridge while live traffic is also underneath me.
Sure.
That would still require a road closure, lane closure. I have flown inside of trusses, but as part of NSTMs, however, I've been in lanes, or we've shut the bridge down for 20-minute periods so I can go and get the data collection that I need.
So we're getting close to end of time here. We're going to have one quick one that I got here. Is evidently there's a pooled fund study going on. Are you guys involved in that, or?
Which pooled fund study?
Which one? Okay, there's several. Okay, well, I guess
several.
So. Yeah,
I guess I have to get on the high horse. Pooled fund study 1620 is for UAS standards. Bridge inspection is on there. So I think some of the questions, what standards? Kathy, I believe there's another pooled fund that you had brought up earlier as well.
Yeah.
It's actually a great question. Check back to the archives. We'll put some pooled fund study references in the documents from this session.
So what's your future, I guess, aspirations with this as far as what you hope to develop in your drone program that you haven't got, what's your goals, I guess, out in front? Obviously, technology changes and different stuff like that.
Well, if I had to put a quick, go Jesse, you go first.
I was going to say, well, for bridge, I mean, I think what I, to have it, we've proved that you don't need the bridge engineers on site to respond to emergencies. So I foresee another response to an earthquake like we had in 2018. It was so cumbersome to walk up and down steep slopes at night. To collect very little data. We were post-holing through on steep slopes and that, through snowbanks, inspecting bridges till 4 in the morning. That, looking back at it, reflecting, had that earthquake have happened 3 years later, it would have been a completely different emergency response. And drones, we would have been safer. We may not have even had to have been in Anchorage. We could have had local maintenance people fly drones, and just like I showed, we can direct them. I can direct Ryan to fly it, or if there was a drone dock nearby, I could fly it to go assess the structure. So it allows us to make a call in a much more rapid response of what needs to be done with that bridge, and then do I need to get there in the field? So it's that first wave. So having that ability to be able to unlock that is just, there's a great benefit.
Yeah.
I'll leave it with that. A nice one, Jesse.
Yeah. Well, with that, thanks guys. Great presentation, good information, and I guess we'll turn it back over to Adirad to wrap things up.
All right. Thanks, Jesse and Ryan, for a great presentation. Thanks, Paul and Rick, for moderating the question and answer period. I noticed that many people joined in the middle of the webinar. For your information, the video of this presentation will be archived on our website, so you can go to our website for the UTC and view the complete presentation. So hope to have everyone back for August 28th, which is our next monthly webinar. And until then, so long.